everybody, John Grimsmo here, bringing you quarantine vlog day one. It is Tuesday, March 31st, and today is that day, Tornos Swiss Lathe Day. So, quick recap, the shop is closed, I own the business, I can come in, the place is empty, sent all the guys home, everybody else is in quarantine and just chilling at home, learning some stuff, and not coming into work, which is good. So I get to come and play. Today's project, this guy. This is the threaded sleeve for our Saga pen. It kind of holds it all together. It does all the magic for the clicking mechanism. Complicated part to make, a lot of tight features. Been setting up this lathe for quite a few days now, on and off, but should be making parts today. So the goal for these videos, I don't know, show you guys what I'm up to. Just bring you along. I'm by myself, so filming is a little bit trickier, but I got the tripod, the GorillaPod, and I'll just try to get some stuff, teach you guys what I'm working on. So yeah, today's Tornos Day, and then tomorrow is gonna be Kern Day. So looking forward to that. So this guy here is the Tornos GT13 Swiss lathe, perfect for making tiny little screws and anything tiny and round and tight tolerance with lots of features. So what I was just working on was routing these coolant lines. I put a 90-degree fitting there instead of them just coming straight out, which is helping already. This is at max Y lower travel. So let me move this guy and show you. It's a tight tamale here. So Y movement, if I move this, then you'll see the Y-axis move up. So you can see those drill bits right there. I gotta be careful. I know they're gonna clear, but you gotta watch it because they're tight. So you can see the coolant lines, they're kind of flopping a little bit. This is a third one that's not plugged in. I'm just going to zip tie it to everything else. I might actually unplug it from the tool, I'm not sure yet. So yeah, you can see the lines are bending beautifully upwards, and that is my max up travel. So they're good. I just got to, keep them out of the way. If I can keep them right here, then I'll be very happy. And then they'll be happy too, and figure out what to do with this guy. But yeah, I've got other through coolant going to the drill bits, the holders, the threading tool, etc. So these let up to 2,000 psi of coolant come out the holder directly at the cutting edge. Like for example, this VBGT, I'm pretty sure it's called. Grooving, threading, tighter grooving, and yeah, all the cooling comes from this chip blaster unit over here. Gets pressurized through these little lines, the 4 lines there, goes up into the machine, done. It's been a good machine for us. Just people aren't joking when they say setups are time-consuming, because they really are. So ideally, you set it up for multiple scenarios, multiple jobs, and a lot of the setup is manual too. Like I'm going in there with a shim, either a paper shim or my little Autodesk ruler. That's not an Autodesk ruler. My little ruler here, and I'm just shimming between the tool and the workpiece. And you just go and you measure the offset of that. Or you turn the diameter and then measure the finished part and then see where you get from that. Alright, I figured out a plan for routing those hoses. I have to replace this bolt with this bolt. So I took 2 M6 nuts and I just cinched them on. This one's backed all the way down. This one's backed all the way against. They're really, really tight. I'm going to go to the grinder. I'm going to grind them down so there's the same outside diameter as that guy. And then it's got to be a tiny little bit shorter as well. And then this should work as a good guide. Let's go to the grinder. All the nice grinders are in the front building, but this is one that my buddy gave me early days, like almost day one of this business in 2011. Little 1x40, 1x42. No, actually it's a 1x30. Couldn't even remember. All right, let's set this camera up somewhere. Where's the grinder? There it is. Alright, success there. I will admit my first instinct was to machine something. But then, you know, this was way faster. Alright, here's the theory. The bolt that I removed was right from here. It covers the gear drive inside that live tool. So I basically am replacing the old bolt with that. And then I can tighten it right from the back. I'll tighten it from there, and then now I have a stopper. Oh, that's awesome. See, look at that. This line was already caught right there just from playing around with it. That's not a good thing. So this is going to be great. So I think that's going to work. I'm just going to move it up and down again. I'll do it right now. Y, X. Gotta be super careful. Like, I know it's gonna clear, but it's still puckery. Yes, those coolant lines look awesome now. Oop, something happened. Oh, I know. Collision risk. I think these tools, when they're that far over and starting to go down, they're not so happy. So I got to move it back to be able to move it down. Move it back. Now I can go down again. And they get tight. I could angle them down, but that doesn't help when I'm up. And as long as that tool is almost perfectly lined up that way, that's as low as I'm gonna go. So I think I'm okay with that for right now. So the Swiss lathe it moves a lot differently than a conventional lathe. Not only does it have two channels, stuff happens on the main spindle, stuff happens on the sub spindle, but the entire y-axis, like we were seeing, moves up and down straight. The x-axis moves straight side to side, and the Z, or Z, is the bar. Let me move to Z. See the bar coming out? So your workpiece actually travels towards the tool, instead of the tool traveling towards the workpiece, like on the Nakamura here. Pretty sure it's off and the door is locked. Yes, it is. So on this lathe, the workpiece there stays still until it's finished, and the tool comes in and cuts towards the workpiece, and retracts. It's just different, but it's awesome. So I decided to also add a manifold. where coolant's going to come in one side and then it's going to feed out 2 or up to 3 or even 4 tubes, so that the 2 extra lines, like that extra one and the upper one, can both go into the same thing. So they can double up, all be plugged in at the same time. Should be great. So right now I'm just, I pipe taped it using my fancy Nipex pliers. These things are awesome. They're like a crescent wrench, but adjustable. And you got this ratchety mechanism here. So at all different sizes, you still have a little adjustment range. And then as you pinch, it self-tightens. And I'm pretty happy with it. This thing is awesome. They're actually way better than crescent wrenches, because I can just let loose and then rotate instead of having to like wiggle it off like a crescent wrench would. And then as you tighten, it doesn't want to break loose. Like, it doesn't want to open the jaws. It doesn't take a lot of pinching force to be able to tighten this. I like these. It holds the jaws really parallel. It's great. Not bad. So I got a swivel fitting on here. I got 1, 2, 3. I'm gonna put a cap on the one that I don't need. Plug on the end. So now my 2 ports will go right there. In case you're wondering, I got these from McMaster. You got a 2-port, you got a 3-port, and you got a 4-port. And they're cheap. They're anodized aluminum. Should be the part number right there. They're great. So I don't think I mentioned this yet, but the lines, they go up, and I used to have them go straight into the tools, and then the cable itself would bend upwards, but I didn't like that. So I installed some 45-degree fittings at the back of each one so that the lines kick upwards, and now they have this easy natural bend to go up and around. And oh, it's so much nicer than before. And I got this guy fully installed. Looks good. Let's give it one last up and down. Pull it back in X, down in Y. Cables are looking good. All right, next up, I'm going to show you what I've been dialing in for a very long time. Every tool. So here's the part that we're making. And if you'll notice, it's got 3 cross holes and a flat on the top of every hole. So these are the 4 tools that I'm going to be using to make all those features. 1/8-inch flat end mill to make the flat, a drill, a reamer, and a little Harvey tool lollipop end mill to deburr the hole, because burrs are no good in there. So basically I'm going to make the flat, and then I'm going to use the lollipop to make a spot, and then I'm going to drill it, and then I'm going to ream it, and then I'm going to go in with the lollipop, and I'm going to chamfer the top. I'm going to stick it in the hole and chamfer the bottom of the hole as well. So tricky little features. And to make sure that all those tools are lined up, so these are all the cross tools that go like this. So that tool right there will spin. It's a live tool. Goes up to, I think, 10,000 RPM. So I've got 1, 2, 3, and then I've got 4, 5 over there, 2 on that side. So 3 on this side, I can go, end mill with my ring finger. I can end mill, I can drill, I can ream with those 3, and then over here I'll put the lollipop right there. Now the trick is, these tools have to be perfectly up and down in Y, otherwise they're going to drill the hole off center. So that's what I've been working on right now, and it's trickier than it sounds. So the way that I've figured out best to do it is I have this little drill bushing, got from McMaster. I like how it's got a sharp edge on one side and a radius on the other. And check this out. This is what I came up with. So I've got them where I think they're lined up perfectly right now in Y, with a carbide end mill just sticking out. Awkward to do this on camera, but I'm taking the drill bushing. Focus. I'm taking the drill bushing and I'm sliding it at the very top, and I'm sliding it over the bar, and then I'm moving the Y up and down ever so slightly while I slide this forward until I feel it catch or not catch. And I'm getting pretty good. And then I go to the bottom and I do the same. That seems to get me close. There's a bit of a variance between the top and the bottom. I don't think it's backlash. I think it's just the way I'm doing it. But I can average it out, and it seems to be pretty decent. So I'm happy with that. Otherwise, like I said, the hole will be off-center, up or down. If you're doing, say you're engraving something on the outside of the part, the engraving will now be off-center. If I've got 2 tools that are in different positions, if I drill it here and then I ream it with the tool that's off, it's gonna suck. It could break the expensive carbide reamer. So I gotta be super careful with that. So getting everything dialed in, I've got 1, 2, 3 dialed in now. I've just got to do 4 and 5, and then setup should be complete, and then I can finally put some brass in, make some parts. So remember how we put that extra long bolt right in there to help guide the coolant lines? Yeah, I just figured out the downside to that. So I've got the Y all the way down, and I'm trying to pull it this way, and watch this guy right here. So, I don't know if I can get in there to see. Let's get some light. Yeah, you can see it. So that bolt head is hitting that sheet metal in this exact position. If I bring the Y up, it'll be fine. Not sure what to do yet. I'll figure something out. So I did my figuring, and I need to come that much shorter. Meaning, this ain't gonna work. This entire stick out can't be here. I mean, I'm not surprised. I'm trying to add something on to a tight measurement, moving object. It just got in the way. Bummer. I'm gonna have to figure out a different solution. Alrighty. Put the original bolt back in. My homemade contraption can just go in the garbage now. That did not work. Failed experiment, whatever. I decided to just zip tie in 2 separate locations, the 3 hoses together. I think that'll keep them where they need to be. It'll keep them going. I'll keep an eye on it over the next few days and weeks. It might just work fine. Easy peasy. Well, hello. So what I'm doing here is I'm using my shim. This is 0214 thickness. And I'm just slowly jogging it forward until this guy stops moving. Notice I'm jiggling up and down and up and down, and it's tight, it's getting tight. Really, really close. I'm moving 1/10,000th at a time, and I think I've got it. I can let go, it's still hanging there. And then I go to the offset screen on the computer, or on the control, and I type in, I want to go diameter of the rod plus 0254 plus 0214 plus 0214. Because this is all diameter in X. So it's diameter of the bar plus diameter of the shim, which is double the actual thickness of it. So 0.2928 is what I type in, and then we are good to go. But this is what I'm talking about with so that's what I'm talking about. It's manually touched off. Almost all the tools in X and Z are manually touched off. Or like I said, you can turn a diameter and measure it, but this gets you really, really, really close. There's a couple other ways to do it. I know some guys love to, especially with the stick tools at the bottom, I can't see them right now. They put them in, they shove it up against the bar, and then they tighten them down. I have personally chipped inserts doing that, so I don't like doing it like that. This way works really good, and then you fine tune, not so much for a drill bit, but with a turning tool, you fine tune it as you make every part. So, but yeah, that has been my day today. Been here for 8 hours, and pretty much what you guys have seen is all that I've done. It's been a day. Yeah, obviously I didn't film or show everything that I did, but there we go. Yeah, it was a long day. I wish I made a part. I hate going home and not making a part. But yeah, I'm gonna finish touching off. I got 2 more tools to touch off, just 1 actually, and then I go home, and then I come in the morning. I still gotta switch the bar feeder, collet, main collet, guide bushing, sub collet, tension everything properly, put brass in, then I can test my code, slowly make a part out of brass. Brass is good because I don't need coolant, so I can see what's going on. And then if that works good, then switch to 17.4 pH H900 stainless steel, and cross your fingers. So that's my tomorrow morning plan. I want to come in early. I want to crush it. I might film. I should. But I definitely want to kern tomorrow. So goal is get this thing running, get it making good parts, and then I don't have to babysit it so much. In the first half hour, I like to babysit it, but then it stabilizes, then it gets really good. And then hopefully I can focus on some kern stuff. Anyway, that was quarantine vlog day 1. Some of you guys found it enjoyable. Some of you guys found it boring, I'm sure. Meh. That's what I did today. All right. See you guys tomorrow. Bye.